So who wins? React Native, Flutter, NativeScript, or Ionic? Now let's generally understand how all these options work before I then dive into the detailed comparison. React Native uses JavaScript as a language, and of course it uses the React library. So generally the idea with React Native is that you build native apps for both iOS and Android with the tools you also use for React web application development. That's the general idea. Flutter uses Dart, a programming language developed by Google. It's therefore not JavaScript, but Dart is relatively easy to learn if you do know JavaScript. So as a web developer, it shouldn't be too hard to learn Dart. And Flutter then is basically a framework for Dart, you could say. It's also a collection of tools, like actually all these options. They also include tools which do the compilation or the translation to native code and that build the native apps in the end. NativeScript, like React Native, uses JavaScript, but it does not embrace React there. It does not use the React library. Instead, NativeScript can be used with vanilla JavaScript or TypeScript actually, and it also supports Angular and Vue really well. So if you want to build a native app with Angular or with Vue.js, so with one of these two frameworks, then NativeScript can be the tool you use there. Ionic, last but not least, also uses JavaScript, because with Ionic you basically build a normal web application. More on that in a second. So speaking of that, you use these different languages, and as you can tell, none of these languages is Java, which you would normally need for Android development with the Android framework, or Swift or Objective-C, which you would normally need to get an iOS app. So how can you use these languages and still get a real mobile app which you can distribute through the app stores? How does that work? Well, React Native, in the end, as I mentioned, like all the other options, is not just a library you dump into your project. Instead, this gives you a CLI, it gives you some tooling which will actually take your React Native project and kind of bundle this into a native iOS or Android app. So behind the scenes, it'll do a lot of stuff for you to give you a native app that kind of uses your code. Now the question is, how does it do that? And the answer is React Native and the tools that belong to it partly compile your code, your JavaScript code if you will, to native code. Now I'm saying partly because what is compiled are actually the user interface components. So if you use the button component in your React code, and with that I don't mean the button you would use in a React web project, but a specific button component exposed to you by the React Native library. If you use that in your JSX code, that will actually be compiled to the native widget for Android and iOS, so to the native equivalent, if you will. Your JavaScript logic, so any Redux logic you have or anything like that, will stay JavaScript and will be hosted on a virtual machine inside of your app, so to say. So the React Native tooling will bundle an application with the compiled user interface, with the real native user interface, as I just explained, and your JavaScript logic running on a virtual machine that's part of that app, so to say. So it's all in one app, which you ship. It's a normal app which you deploy to the app stores, but it includes this native user interface, and then your JavaScript logic and React Native also ensures that these two things can talk to each other. That's how you can think about that. Now for Flutter, it's a bit different. There, Dart indeed is really compiled to native machine code, if you will. Flutter, like React Native and so on, includes tooling that does that. And here the idea really is that therefore you get a native app that's made up fully of machine code. One important difference to React Native, for example, is that Flutter and Dart don't really take, let's say, a button and compile that to the native Android or iOS button. Instead, that all gets compiled down to native code here that runs on the machine, you could say, and Flutter really controls every pixel on the screen manually. So it doesn't compile to any native equivalents, to any native widgets. It compiles everything to code that directly runs on the machine and therefore renders something to the screen. That's how you can think about this. Now, NativeScript is closer to React Native. There also the template, the user interface gets compiled to the native widgets, to the native equivalents, if you will. So any state management, code that sends HTTP requests, all of that stays JavaScript code, which, like in a React Native code, is embedded in your application and is able to talk to the user interface. So again, NativeScript gives you some tooling that creates that bundle and that does this connection of JavaScript and compiled user interface. Now for Ionic, the approach is a bit different. There, no compilation happens, neither for the user interface nor for anything else. Instead, with Ionic, you build a normal web app, and what Ionic gives you is a wrapper. It gives you a native app, it gives you a real native app. All these options generate real native apps, but Ionic basically gives you a native app that has a web view in there that hosts that web page which you're writing. So you're just having a web page encapsulated in a native app, if you will. This is a great approach when it comes to building the app because you don't need to learn anything specific. You just build a web app and you get a native app, which is pretty sweet. A minor downside, and I'll dive deeper into that in a second, is of course performance because you have that wrapped app. But I'll say way more about this later in the video because it's not as simple as it might seem. Now, what about the languages we use there? We use JavaScript instead of Android, or Java with Android, and instead of Swift and Objective-C. Is that a good idea? Well, JavaScript wasn't invented for this, but if you work with React Native, if you have a look at apps that were built with React Native, it turns out that this works really well. The same for Flutter and Dart. Dart is older than the Flutter project, and Dart wasn't invented for this. But just as JavaScript did, works really well, the compilation works really well. They spent a lot of work ensuring that it does. And of course, it's an advantage that both Dart and Flutter are developed by the same company, which is Google, which of course means that they go hand in hand during the development, and Dart can be optimized to really suit Flutter and the other way around, if you will. And that's of course not really the case for all these other options because their JavaScript is not developed by the teams behind React Native and NativeScript and Ionic, so they can only optimize their libraries and their solutions for JavaScript and not the other way around. So we get the same arguments here for NativeScript and Ionic as for React Native. Now, another important thing when we think about building these native apps is not just which language we use and which framework or library. There, as you saw, you can use React Native with React, NativeScript with Angular or Vue. Ionic, I didn't mention this, but Ionic can be used with any framework or no framework at all because you just build a web page, so you got total flexibility there. And Flutter uses the Flutter framework, so that's one important thing. But the question is also, when you build these apps with the supported web tools, web technologies, web frameworks, which extra features do you get besides the tooling to build a native app from that? And by that I mean, how easy is it to build user interfaces? Because for that you need some native components. You need buttons that look and feel like the native buttons you're used to from mobile apps. You need sliders that work great with touch events, and so on. And there, React Native ships with some, but only a few, pre-built components which partly adapt itself to the underlying platform. And with that I mean that the styling and maybe also the behavior changes when this component is then used in an app running on iOS versus the same component in the same app running on Android. So React Native really has a minimalistic approach there. You get some core components with which you can actually build any kind of interface, but you will need to build more components on your own. There only are some pre-styled, pre-configured components in there, which sometimes then even adjust themselves to the underlying platform. For Flutter, it's different. There you got a huge suite of components. Flutter is all about components, widgets as they call it. And in Flutter you got so many widgets, you can basically build any user interface with all these widgets. You don't have to reinvent the wheel. In many cases there is a widget which you can use, which you then can configure to suit your needs, which you can style, but which generally is there and which you don't need to invent and build from scratch. And quite a few of those components or widgets also adapt themselves to the underlying platform, which means that a slider on iOS looks like a slider should feel on iOS, but if the same app is running on Android, it looks and feels like a slider should feel like on Android. Now for NativeScript, We got some pre-built components. Most of them, or quite a few of them, are adaptive, but not as many as we have in Flutter. But it's a bit better, a bit more than with React Native, I'd say. But generally, React Native and NativeScript are comparable, but NativeScript gives you more components that work and look good and adapt themselves than React Native does. Now for Ionic, you again got a huge suite of components for everything. So like Flutter, you got many components and they're basically all adaptive. So all these components which Ionic ships adapt themselves to the underlying platform. And indeed, Ionic primarily is actually a library or a framework for web components. So components which you can use not just when you want to build a native mobile app, but also if you want to build a normal web app. Ionic, or the team behind Ionic, then just also gives you tools to get a native app out of that, to build a native app. But primarily, Ionic, if you just take the Ionic framework itself, is just about having these pre-styled, pre-configured, and still fully configurable by you components, which you can dump in any web page. So you can also use Ionic in non-native apps if you want. So that was the overview. Let's now compare all these options. And for that, I came up with a couple of categories which are totally subjective, which are just reflecting my thoughts and ideas. And therefore, you are more than welcome to comment in the, comments, surprisingly, and share your thoughts on that. And maybe also share some other categories which I don't have in this comparison. So the first category I came up with is write once, use everywhere. So this quote here. What do I mean with that? Well, if we have a look at all these options, the question is, how much code do we need to write to get apps for both operating systems, so for iOS and Android? Now, you could also include getting a web app into the equation, but that's not really what the video is about. So I'll just focus on iOS and Android and see how much code needs to be written to get apps for both platforms. Because in an ideal world, we only have one code base, one project, which then gives us apps for both platforms that then still feel like they should feel for the different platforms, which means that they look different on the different platforms and that some behaviors are different. In an ideal world, we don't have to write much code to achieve that. So we could have these two extremes, that we write code only once and that we write it twice. Now let's throw in the native languages, Java and Swift or Objective-C. Obviously there we have to write it twice because the Java Android app only gives us, well, guess what, an Android app, and the Swift Objective-C app is just an app that runs on iOS, and we can't share the code. These are totally different programming languages, so if we want to have an app for each operating system, well, then we have to write two apps from scratch, basically. Now, the other end would be Ionic. Since we build a web app and we have this rich suite of pre-configured components which automatically adjust themselves to the underlying platform, we don't have to write much code to get two apps that we can ship to the two platforms that still look and feel distinctively different on these platforms. React Native would be somewhere in the middle, maybe a bit further to the right, but that really depends on the kind of app you're building. It's in the middle because React Native doesn't have that many pre-built components in there, so you need to build many components on your own. And if these components then should look and feel different on Android than they do on iOS, you have to add your own logic. You have to throw in an if check into your code and say, if the platform this app is running on is Android, then do that, otherwise do that. You can do that very easily in React Native, but it still means that you have to write some extra code. For NativeScript, it's about equal, since it has a bit more components which automatically adjust themselves. It's a bit more on the left, but as always, it depends on the kind of app you're building. Maybe you're building a very specific app where you need to write up a lot of custom components, then this all shifts more to the right, but that's generally where you could categorize this. Flutter is a bit more on the left because it has many built-in components, and more of those components adjust themselves to the underlying platform, and they're highly customizable anyways, so you can also find a style that suits both platforms. But again, it depends on the app, and you might very well also build an app where this should be shifted further to the right because you need to do a lot of manual adjustment. Because just like in React Native and also in NativeScript, in Flutter you can also say, if platform is Android, then do this, otherwise do that. So it really depends on the app, but this is generally how I would categorize this. Now, kind of connected and still totally different is my next category. Learn once, write everywhere. Now, what do I mean by that? This means that we can have an application, or that we want to build an application, and we might be fine with writing a bit more code, with writing some if checks to check on which platform we're running, to then render different components or different styles. But the logic we learn and the code, the language, the programming language we learn, that should at least be the same. So here we also have two extremes. We need to learn once, we need to learn twice. And unsurprisingly, if we use the native languages, we're on the right, because Java and Swift and Objective-C might have some similarities, but they are totally different programming languages, and you have to learn them from scratch. You have to learn two different languages here. Now for Ionic, of course, we are on the left because we work with, we build a web app, we build a web page. And even if you aren't a web developer yet, well, you just have to learn the web technologies and you can get two different apps for two different platforms. So you learn it once and get two apps. Now, it's the same for React Native and also for NativeScript and for Flutter. They're all here on the left, and you can move these arrows around. They're basically all using one language, one library in the end, which you can then use to get two native apps. So we're definitely on the left there. Now, also important when building a native app is whether you have a rich pre-styled component library available or not, because that obviously simplifies building the app and speeds up the app building process. If you have to build and style and configure all components from scratch, then of course that takes longer than if at least a broad variety of core components is already built into the solution you're working with. So here I got these two extremes, all you need versus build and style yourself. And for the native languages, we're actually on the left here, because these native languages give you the widgets you need there. Obviously, they're all about allowing you to build an iOS or Android app. So whilst you can't share the code, if you build an iOS app with Swift and with Xcode, which is the development tool Apple gives you, then you have all these default components available, and that's really easy to work with. Ionic is also on the left because, as I mentioned multiple times, it gives you a rich suite of components which you can use. React Native is on the right because React Native only gives you a few core components which have no or only very basic styling, and which you then need to style and configure on your own, and where you need to build your own components which are composed from these core components. So there you have to do a lot of that work on your own, and there are some third-party component kits which you can use. But for one, these might still not offer everything you need. In addition, you then depend on this third party to maintain the kit and so on. So React Native on its own doesn't really have a big component library built in on which you could rely. NativeScript, somewhere in the middle, has quite a few built-in components. You might still need to build a couple of components on your own and style them yourselves, but it definitely has more than React Native. And Flutter, as I also mentioned, has a huge library. Not all components are adaptive, so that might require some extra effort to make all components look the way they should look on the different operating systems, but that's getting better and better. There has been a lot of development on this over the last year, and therefore this is really not that bad here. Now, before I switch to the next categories, one word about the future, the past, and the prospects of all these options here. Now, I did this comparison a year ago, and especially Flutter has gone a long way since then. It got much better, has more components built in, a lot of bugs have been fixed. So this definitely shifted into the better directions on most of these categories here. And also NativeScript and also React Native has seen some development here. So generally you could say all these options really got better since my last comparison. Also for Ionic, for example, Ionic 4 was released, which was a huge thing and which really helped Ionic and has made it even more awesome. And below the video, you also find a link to a video where I talk just about Ionic 4 and what that offers. On to the next categories then. What about the ecosystem and the third-party libraries? That is important because none of these options has everything built in. You might need certain features, certain native device features, like using the camera, which is not supported out of the box, where you would have to write your own logic to access that. And therefore, it of course matters how active the ecosystem is and which third-party libraries you find there. The ecosystem does also not just include third-party libraries, but also how many tutorials you find and how much help you're getting. So if we plot these different options here, well, obviously for Android and for iOS development, you find tons of resources, tons of third-party libraries, tons of tutorials, courses, help documents, official docs, and so on. Of course, these are huge ecosystems, so there's a lot in there. For Ionic, it's also very good. Ionic itself is popular, but not even close to, of course, native Android and Java. None of the options I show here is, by the way, of course. But Ionic allows you to build normal web pages, right? And the web development community, in turn, is really large. It's really large. There are tons of third-party libraries. And generally, you can use any library, which you can use in a normal web page, also in an Ionic app. So that's really great. When it comes to using native device features, that's also quite decent. Now, for React Native, it's also very good. It's also a web app. It's a React app. And therefore, since you have that restriction that it must be React, it can't be any web app, it's of course a bit further on the right than Ionic is. But React is popular, web apps are popular, and React Native itself is also popular, so you will find plenty of resources there. Though I will say the ecosystem of React Native is really good, you find a lot there, but a lot of the core features which you need in many apps are actually outsourced to the community. So for example, native modules for working with Google Maps or anything like that, that is all handled by the community, and that is indeed well maintained. But it's not on the same level as if the React team itself would guarantee that they develop this and that they're really behind that. NativeScript, there it's a bit worse. You have a lot of plugins or libraries managed by the NativeScript team. That's great, but NativeScript just isn't as popular as the other options. The ecosystem, the community is way smaller. Unfortunately, because NativeScript really is a great tool, great technology, but it's just not as popular as the other options, and therefore you have a smaller ecosystem there, you have fewer resources, for example. Flutter is somewhere between Ionic and React Native, I'd say, simply because a lot of core features are baked in, so you rely a bit less on the ecosystem, and the ecosystem is really great. Especially over the past year, it has grown tremendously. There are so many third-party libraries, lots of discussion on Stack Overflow, lots of tutorials and documentation and so on. So that's really good, I'd argue. Somewhere around the React Native level, maybe a bit better, but as always, it depends on the app you're building. Now let's talk about popularity. And that's of course kind of related to the ecosystem, but here I really mean at how popular it is when we talk about available jobs, available projects, and in general, how hot is the topic. So if we have a look at this, well, obviously Java and Android are very hot. These are huge topics. You find tons of jobs and so on, so that's really popular. Not much to say there. Ionic is somewhere in the middle. If we have a look at the it's a web app aspect, it's obviously very popular. Web apps are very popular. But if we have a look at just Ionic, the Ionic framework and solution itself, well, then that's a bit smaller, obviously, because it's kind of a niche solution still. And whilst you have a nice and helpful community there and everything, I'd say it's somewhere in the middle. Now, since you can build Ionic apps with any framework, be that Angular, Vue, or a library like React, you also benefit from the popularity of those solutions. So that's a tiny plus, and therefore, yeah, somewhere in the middle. React Native a bit more on the left. React is very popular. React Native also is very popular, and therefore, I'd say a bit closer to these native solutions. So this is of course all meant relatively. It's not an absolute measure here. If you would have a look at absolute numbers, the distance between the native languages, Java and Swift, and the other options would probably be way bigger. NativeScript, as I mentioned, is just not as popular, unfortunately, and therefore it's further on the right, even though it's great, but just not as popular. Flutter, I'd say, is roundabout on the same place as React Native. It is popular. It's also growing in popularity, especially the last year was awesome. Flutter is really getting more and more popular, so we can be excited about what it will bring in the future. And therefore, I'd say at the moment, you can definitely plot it at this point. Now, the next category I want to have a look at is performance. The performance of the app you're building, of course, matters. It matters whether it loads fast, but also whether it then runs fast, or if there are lags or delays or anything like that. Now, it's needless to say that generally, native apps written with Java or Swift or Objective-C are pretty fast because there's nothing in between. This is as native and as intended to be used as you can get, obviously. Now, Ionic would be on the other end of this scale, because there you build a web app which then is wrapped by a native app which just loads the web app into a web view. Now, obviously, of all these options, where at least some compilation happens for the other options, this has to be the slowest approach. But it's really important to kind of put this into context or in a relation here. It's not the case, and absolutely not what I mean here, that Ionic apps are slow. Just of all these options, they of course tend to have the worst performance, but that is not a must-be, because it's always possible to write bad code with any solution, so you can definitely build a React Native app that's way slower than an Ionic app. So that's one thing. And in addition, the performance difference I'm talking about is very, very small. And on most, pretty much all modern devices, you will not feel it. Also, especially with Ionic 4, performance of Ionic apps got much better. Also with their own tool, Capacitor, which is the tool that actually takes your Ionic web app and allows you to put it into a native app. And therefore, it's really easy to look at this and think like, Ionic is slow. No, it's not. Ionic is not slow. It might even be faster than some of the other options, depending on the app you're building and the code you're writing. But even if it is slower, if there is a performance difference, it will not be measurable and will not matter in many, many, many scenarios. So don't rule out Ionic just because you read somewhere that it's slow. React Native now certainly is closer to the native solutions than Ionic though. And again, this is not an absolute scale here. This is just some relative, subjective placement of these options. So React Native is of course closer because the user interface gets compiled there, which is great. Your JavaScript code in general does not get compiled though. That's hosted in React Native. But still, you get pretty well-performing apps with React Native. Same for NativeScript, not much to say there. It follows a similar philosophy. Flutter, certainly a bit more on the left, and you could even have more distance between Flutter and React Native and NativeScript. It really just depends on the kind of app you're building. Since with Flutter, everything gets compiled to native code and every pixel gets controlled by Flutter, you have the potential for a bigger performance gain, but you also have a bigger opportunity of writing bad code that leads to slower performance. So therefore, you could have a bigger difference between Flutter and React Native, but you can also build worse performing apps with Flutter than with the other options, but you can also build way better performing apps. Theoretically, you could even build apps that are better performing than with the native languages, because no compilation to these languages happens, but Flutter controls every pixel on the screen manually. That's how you can think about that. So that's the performance. Really important to not just look at the chart, but to also reflect what I said about Ionic and performance differences and the code you write, which matters. And with that, onwards to the next category, almost the last one. And this is how easy it is to access native device features. And obviously that also matters. If you're building a native app, you want to use the camera, you want to use the user location in some apps, and therefore it matters to know how easy that is or how hard. Now, of course, if you're using Java and Android, it's very easy. It's all built in there. You got native APIs provided by Apple, provided by Google, which make that very easy. For Ionic, we're a bit further on the right, though it really depends on which feature we're talking about. Ionic, and with their capacitor project, which is run and developed by the same company, you got access to a lot of core native features in a very, very simple way. So if you're just working with some basic, simple features like the device camera, you could definitely move that further to the left. It's also worth noting that Capacitor, this project developed by the Ionic team, which helps you get access to the native APIs, actually even works in non-native apps, so in web apps. Of course, not all APIs are supported there, but a lot of APIs are supported, and there it's then also still easy or very easy to, for example, open the camera, the webcam of the user and take a picture. So you can move Ionic way further to the left if you're working with basic features. Now, if the features are not basic, however, you depend on third-party libraries or you need to write your own native code, and that can be harder here. So that's why I put it there, but again, you could move it somewhere else depending on what you're building. For React Native, we're a bit further on the left, I'd say, though again, it also depends on the app, but especially if you're building your app with Expo, which is a tool that simplifies building React Native apps, you could say, then you got a lot of native features easily available, just a click or just a code line away. And if some feature is missing for some reason, you can write your own native code and connect this to your React Native app. So I'd say it's generally a bit easier than with Ionic. Now, for NativeScript, we're even closer to the left because there you also got a lot of features built in or in packages managed by the team behind NativeScript. That's different for React Native. As I mentioned, with Expo, a lot is built in, but Expo, this tool, is not managed by the React Native team, so you rely on some third party that it keeps maintaining its package, its tool, which is likely but not guaranteed. For NativeScript, since most native modules and packages are maintained by the NativeScript team, the chance of those packages being maintained in the future is a bit higher, I'd say. In addition, if you need to write and connect your own native code, that's currently a bit easier with NativeScript, though it will also become easier with React Native without Expo in the near future. Flutter, somewhere in the middle. Flutter also has a lot of native APIs, native features baked in. A lot of core features are maintained by the Flutter team, just as it is the case with Ionic or NativeScript. And if you need to connect your own native code with Flutter, that's also a bit easier than with React Native at the moment. And with that, onwards to the last category, real-world usage. Now, there I got these two extremes. Facebook and my first app. So the idea simply is, how are these options getting used for real apps? Now, of course, we got a bunch of real apps out there in the app stores, which are built with Java and Swift or Objective-C. The vast majority of apps there is actually built like this. Now, for Ionic, somewhere in the middle, again, this is not an absolute measure. Otherwise, all options would be totally on the right. But Ionic is nice for building your own dummy apps, but there also are some real apps published on the app stores which are of different size. And if you Google for Ionic Showcase, you will find this page which is continuously updated where you see some of the apps built with Ionic which you can find in the app stores. How about React Native? Well, that's a bit hard to categorize. I'd say it's pretty good. Because if you check out the official React Native showcase, you see quite a lot of apps which you know are built with React Native. It's just important to note that not all these apps are built with React Native only. Instead, you can indeed use React Natives in parts of your apps, where the other parts are built with Android and Java and iOS, Swift, Objective-C. So not all the apps listed here are built entirely with React Native. It's hard to tell which apps are built entirely with React Native and which aren't. For example, Facebook and Instagram, to my knowledge, are using React Native in parts of their app, and not the entire app is driven by it. Facebook Ad Manager, on the other hand, to my knowledge, is powered entirely by React Native. So React Native is getting used in some major apps, but not necessarily the entire app is powered by React Native. It is also worth noting that Airbnb quit using React Native in the last year, but on the other hand, since then, React Native has come a long way, and many of the issues Airbnb found in there were being fixed, or the React Native team is working on fixing them at the moment. Now for NativeScript, it's harder. There we find less real-world apps simply because it's not that popular. If we have a look at the NativeScript showcase, we see a couple of big names there, but a lot of these apps are kind of internal apps, so used inside of the company, or niche apps. So unfortunately, there aren't that many big applications using NativeScript. Now for Flutter, that's also a bit hard to tell because Flutter is still relatively new, but especially in the last year, it has grown a lot. If we have a look at the Flutter showcase, we find quite some big apps here, which to my knowledge are indeed built entirely with Flutter, where we see that big companies like Alibaba or Google are using Flutter. Well, of course, Google is developing Flutter, but they're using Flutter for their Google Ads application and so on. So still not the super big app names in there, but I'm pretty sure we'll soon see more and more apps there. And we already have quite some nice apps in here. Hence my positioning here on the chart. Well, and with that, that's it. Now, as I said at the beginning, this is totally subjective, and all these technologies are also under highly active development. Especially over the last year, a lot has changed there. Not so much in my charts, but in the technologies, in bugs that were fixed, and in the ease of use. I think all these options are worth checking out. At least it's worth having a brief look at them. Now, of course, if you're not a React developer, doesn't make sense to use React Native. If you never worked with Angular or Vue, NativeScript might not be your option. Ionic is nice because you can build full web apps with it, even if you don't want a native app, and you still get nice looking web apps, which you then can easily transform into a native app. So it's nice to have that as a bonus. And Flutter is pretty amazing because it's growing so strong, because it's so popular, and because Google really seems to be going kind of all in on Flutter. So that's also exciting to watch. But ultimately, as so often, it's up to you to have a look at all these options. And with have a look, I don't mean learn them entirely, but dive into some dummy apps, dive into some examples, get a feeling for how it works, build some very basic apps with the help of some basic tutorials, and then maybe pick your favorite there. It's really great that you're able to build native apps for both platforms with one code base, and therefore I'd say it's definitely worth learning at least one of these options if mobile app development is a thing for you, because you can save a lot of time there. So I hope this was helpful, and I hope I also see you in future videos.